pretty sure y'all have done these before, correct?
Yes.
No. For the properties of numbers. You have.
I don't recall.
You started these in the 6th grade. So the first thing that we're going to talk about, because today we're going to be defining and creating examples. It is very easy. So the first thing that we're going to do is the reflexive property. Now, reflexive means that it's like a reflection, correct? Open this. On the left side, we're going to write our definition. On the right, we're going to write examples. Is everybody with me? Alright, so reflexive property means that it's a mirror or a reflection. It also means that something is equal to itself. So my first example that I would say is very easy. A equals A. Look at us go. That's the reflexive property. If I wrote 4 plus X, it would have to be 4 plus X. Has to be the same thing on both sides for it to be the reflexive property.
So that would be, could we like put that as 8 plus, no, today we can try to be like 8 plus 2. Okay, let me try.
But yes, if I said A plus 2X, it has to be equal to A plus 2X.
I was going to combine like turn.
No. None of those are like terms. Now please do your push-ups. Does anybody have any questions on the reflexive property? Easy peasy? The symmetric property. What is symmetric? So like if you cut it in half and fold it up, it matches? Okay?
Like a line of
Yes. That's not a push-up, but I will gladly record you doing push-ups and send it to your coaches. I don't know why we have to do this every single day. I'm so tired of you saying words that you shouldn't say in class. Alright, so symmetric is the same but opposite. So reflexive property is it's the exact same thing on both sides. Symmetric property is if I said A plus 3, I would have to say 3 plus A over here. If I cut it in half and fold it up, the 3's touch, the pluses touch, the A's touch. If I said 6 plus 12, what would I have to say on the right side? Look at us go. If I said A equals B, what would I have to say on the right side? Look at us go. That's it. That's the symmetric property.
Wait, why do you need to use this?
In case I ever ask you about properties of numbers.
It's not like really use it. What if you did 6 minus 3, 3 minus 6?
That would not be the same. Because subtraction doesn't work like that. Right. But I like that example. Good job. Alright, transitive property. Transitive property is like the transit, which means that you move from one place to the other. Transitive property. Everything is equal. A transitive, things move. Moves, Blair. Moves. I just wrote the word transitive. And yes, Blair is my name. Take the wheel and pass us into the river. Alright, so like if I said A equals B and B equals C, what could we then say?
C was A. And B was B. Look at me go.
So if A equals B and B equals C, take out the middle, A equals C.
Oh.
Wait, don't go yet.
Okay. That's all it means. Transitive property, you take out the middle and move it together. Alright. If I said A equals B, B equals C, and C equals D, what would be true? Okay, so A equals D, that's 1.
And then B equals D equals D.
B equals D, that's 2.
Equals C.
A equals C. Yep.
That's 1.
Okay, Pumpkin, are you ready?
What about B equals
I'll let you write it down and then I'll say it. No worries.
What about B equals C because you take out the middle?
We say that.
What if A equals B?
We wrote that. We already said that.
No, B.
So we said that A equals B and B equals C and C equals D. Right? So the first thing we do is we take out everything right here and slide it together. Because they're all equal. Why are you staring at me? Then I could take out this and slide them together.
Oh.
Then I could take out this and slide them together. Okay, Pumpkin. A equals B. Okay, Tater. A equals B. Right? And B equals C. Throw it again and it's mine. It already is mine. Throw it again and y'all never use them again. So we know that these two are both equal to B, right?
Yeah.
Take out the middle.
Okay. So
Now, yes. Now we also know that C is equal to what?
D.
Okay? But we know that C is equal to,
D.
take out the
Oh,
middle.
I get it. So it's like that one and that one.
Yep.
And they're like equal.
And then you can take out all of the middle and put them all together.
Yeah.
Yay! I like that. I like when the light bulb goes off. Alright, substitution property. The last one on this page. Alright. Stop. Separate. 2 of you go to that table. I don't care which 2.
Oh, bro, I already called it.
Yep, that's perfect. Sit down.
They should have went up.
No, I wasn't even the one talking about
Not at all. Alright, substitution property. What does the word substitute mean? Replace. No judgment. All God's children. So substitution is replace. Ask her if she's a killer. Hello.
Hi.
Give this to the sweet girl in, I think, your next period class.
Yes.
At least become friends.
Thank you. All right. So if I say that n equals 12, and I said that we had 4 n, what would we replace n with?
Oh, wait.
No.
12. Because it says n equals 12 and that's an n.
So that's 4 times 12. Ta-da! That's all you do for substitution. Right? So if I said that x equals 5, and I said 3x minus 7, what would we replace that x with?
Hi.
Why?
Because that's what a variable is.
Look at us go. And boom, we're done with the yellow page. Purple next. Why do you have to remind him so that he starts crying again? You are. Now, purple. Now, these are just 4 properties. The back properties, the purple, have to do with addition. So we have associative property of addition, and we also have the associative property of multiplication. They are almost the same thing, except one deals with what? And the other deals with? Your geniuses. Open this page. On the left-hand side, we're going to define our properties, and on the right-hand side, we're going to do examples, just like we've been doing. The associative property is how you associate things. It's how you group them. So your associates are people that you talk to, right? Or work with, or associate with. And this is a group. And no matter who they work with, they're still a group, right?
Yes, ma'am.
They're just talking to different people at the moment. So associative property means that the way you group numbers doesn't, Blair, change the sum. And sum is add, because we're on the addition property. Ready? So my example would be if I said A plus B plus C, I could also say A plus B plus C. So associative is with grouping. It's with parentheses. So if I said 7 plus 3 plus 10, how could I write that differently on the right side? And where do my parentheses go?
Around.
It's not indentation. Get it right.
Oh, stop it. Does everybody understand?
Yes.
Identity property. What is
Oh my gosh.
5, 4, 3, 2, 1, blast off. Identity property. What does the word identity mean?
It's like yourself.
Identity theft is who you are, right?
Have you seen that movie?
Yes.
So identity means that you stay the same. Well, hopefully you evolve, but so with addition, if I want to add something to A, but I want it to stay the same, what do I add to A? 0. You get a point for your team. So it's any number. Do y'all want to be your own team?
Yeah.
Okay. Hey, we need a slip.
Plus 0. May I please have a slip?
May I please have a slip?
There we go. Any number plus 0.
Okay.
So my example could be, pick a letter.
H.
H plus 0 equals H. Alright. R plus what equals R?
0.
I could have a flower. Plus 0, and it would equal what?
A flower.
Is it the same?
I'm proud of you too, best friend. So I can't be proud of you? I take back my pride.
Oh,
You're working your way towards it.
I was. Yes, we all know.
Alright, now, commutative. Anybody have any questions about associative or identity? Okay. Commutative. Commutative means that you commute back and forth. And no matter how the route you go, you're going to get to the same place. So I could go like 4 different ways to get here, but I'm still going to end up here. Yay. So, commutative property says the order in which you add numbers does not change the sum. So associative dealt with how we grouped them with parentheses, right?
Yes.
Commutative deals with the order that you write them. So I could write A plus B plus C, and that would still be equal to B plus A plus C. It's still the same thing. Magic. That's all it means.
Like if you change the order.
Now, it's only when you add them, because remember that activity we did with our order of operations, and we changed the order of our operations, and we got different things? It's only like this, y'all. Either all addition or all multiplication. So what if I said 6 plus 3 plus 9? How could I write it on the right?
3 plus 6 plus 9.
Ta-da! And the last one, I think the distributive property is silly. Let me qualify that. I think the distributive property of addition is silly. You know how to distribute, right? And you distribute, you do. You distribute when you can't combine like terms. So, for instance, if I had 3 times x plus 2, I would distribute, right? So the distributive property of addition says that if you have 3 times 2 plus 5, you could use the distributive property and still get the same answer if you use order of operations. I want you to use order of operations because but I got to teach it to you, so here we are teaching it. So we're going to write, this is silly. Use order of operations. But you could, in theory, do 3 times 2, 3 times 5, and then add them together. And you would get the same answer as if you use order of operations. It's just another way to look. I don't know. It is. Are we ready? Green paper! Now, we are doing the associative property of multiplication. It is the exact same thing as the associative property of addition, but with... Take a point, Deja. So, it says that the way you group numbers doesn't change the product. Okay, no worries. I just didn't know where you went and it scared me. The way you group numbers doesn't change the product. Let's go. Fast. So if I said A times B times C, I could also say it as A times B times C. Remember, associative property is your grouping symbols. It's parentheses, and you move them around, and we're done with that one. Unless you really want another example.
No, we're fine.
Are we sure?
Yes.
So associative property is parentheses, right? Parentheses. Can you button your shirt? It's the principal. I've already asked you to do it once. All right. Identity property of multiplication. What is identity again? The same thing. So what would we use for multiplication for it to stay the same? Times 1. Yes. Take a point, Aaron. So it's any number times 1. Why would it not be times 0?
Because everything that I'm doing, 0.
So if I said A times 1, what would that give me? What would it give me?
1A. What is A? That's just A.
It's A.
If I said 4 times 1, what would it give me?
4.
If I said smiley face times 1, what would it give me? Yours or mine? Oh,
We
thanks.
can use it always.
Pardon?
We can use it like always, like not.
I know. So we should be pros, right?
Yes, no.
That's what I like to hear. Commutative property. What does commutative mean? But how?
Like,
No matter what you're
Parentheses.
That's associative. Commutative is...
A group, a family.
Baby, we already said that.
is that not
I
right?
don't know what it is.
It is, but I want more.
more.
Okay, so associative is if they pair together and they pair together and she's chilling by herself, this is still a group, right? Commutative is if they switch seats, they're still a group, right?
Yes.
So commutative is moving. Commutative is moving.
I thought that was translated.
Same, yes. They relate to each other. So the order in which you multiply, so it's the order, remember? We wrote that down a second ago. Numbers does not change the product. So if I say 6 times 3 times A, what's another way I could say it?
8 times 3 times 6.
And I'm still going to get the same thing. Take a point. If I say 11 times negative 4 times 76, what's another way that I could say it?
Negative 4
Dun, 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 dun.
He's gone.
I know, we'll still do the same thing. I have an answer. Yeah. This is like my 3rd year teaching for him. He knows how I am. No. No. Yes. Alright, distributive property of multiplication. It is another silly one. This is silly. Use PEMDAS. But ultimately what it says is if I say 6 times 3 times 5, I can distribute that 6 to the 3 and the 5. But you just need to use order of operations. We have dos más and then homework. No. 3 more. 3. And homework. It's easy. Zero property of multiplication. Sit, child, before I hurt you. What do you think this is?
Anything times 0
Is?
equals 0.
Look at us go. Yes. Yes.
Oh, can I take a point?
No. Yes. Anything times 0 is. So if I say 5 times 0, that's. If I say rainbow times 0, what's that? 0. If I say brownie face times 0, what's that?
0.
Dun, 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 dun. Alright, last 2, flip it over. I forgot to make flappies for these. You will survive. Hold on. The first one,
Do we make the back of the shape 3D?
yes. Additive inverse. Inverse means opposite. Additive inverse means add the opposite. You get 0. So if I have A, I'm going to add negative A, and I'm going to get 0. If I have 3, I'm going to add negative 3, and I'll get 0. If I have 5, I'm going to add
Negative 5.
and get 0. If I have negative 7, what am I going to add to it?
7.
And I'm going to get,
Then 0.
and the last one is multiplicative inverse. You get 1 when you use the multiplicative inverse. And it means flip it. So if I'm trying to multiply 5 and I want to get 1, I'm going to flip 5 over 1/5 and I get 1. The multiplicative inverse is also called the reciprocal.
Oh, I get it. Yeah, that's what we used to use.
6, what would I multiply 6 by to get 1? 1/6. What would I multiply 3 by?
3, 1/3.
What would I multiply 1/2 by?
Half.
2. Take a point, whoever said 2, and you get 1. And that's it, and I'll give you your homework sheet.
Okay, that's fine. I like it.